Okay, let's quickly try and understand how we can do binary file processing in Visual Basic. Let's say you want to store data in a binary file related to a student, right? So what we can do for that is that we can create a record, right? And we do that using the keyword structure, right? This is the keyword that we use in Visual Basic to create a record, and our record, the identifier of our record is student, right? So we're trying to define a student record, and in this record we have a name, an ID, and a height, right? So the name is a string value, the ID is an integer value, and the height is a decimal value. Okay, next what we've also done is we've created an array of the data type student, right? So this array is going to be holding records related to students, right? So now that we've declared an array, what we can do is we can populate this array. Okay, this code here, what it's doing is it's taking input from the user and it's storing that input into the record, right? So the name is being stored here, the field ID is being given a value by the user, and the field height is being given a value by the user. So this loop runs 100 times, and basically all the records in our array are now populated, right? So we have 100 records in our array now. Next, now that we have an array which has all the data, all the student records, what we want to do is we want to save this data that is in our array. We want to take it from here and we want to save it on a file on the hard disk, right? We want to save it on a binary file on the hard disk. Okay, and what we've done now is that we've created a connection with our file, right? And we have set up a file stream, right? So just think of this as a connection that you've set up, right? And this is the file that we want to write to. Okay, so this is the file in which we will be writing. So we've given the path of the file, and note that I've given the path of the file within quotes, right? Okay, and finally I've given the mode in which I want to open this file, right? For example, there are three modes that I can use. There is the create mode, which creates a new file. There is an open mode, which opens up a new file, which opens up an existing file. So this opens up an existing file, right? And let's say I should be using what? I should be using a create mode here, right? Because I want to create a new file. Okay, and the append mode opens up an existing file and goes to the end of the file. So all data that you are going to add is going to be added to the end of the file, so it does not overwrite data. Okay, the create mode will create a new file. So just remember, this is a line that you need to memorize. Okay, whenever you have to work with binary files, first you must set up a file stream, okay, and you must include the path of the file and the mode in which you want to open up the file. So this is the identifier of the file stream. Okay, now that we've opened up a file stream, we want to and you can think of a file stream as a connection, right? So we've opened up a connection on this connection we want to write. And remember, since we are working with binary files, therefore we are going to set up a binary writer that is going to be able to write on this new connection or this new stream that we just created. Alright, so now that we have set up our connection, we've opened up our stream, we are going to use our binary writer, and I should have the word new here, right? Because trying to create an object. So it should, instead of this, it should actually be dim bw as new binary writer, and this binary writer is going to be working with this file stream. Remember, fs is the identifier of this file stream, right? So this binary writer is going to be working with this file stream. So now that we have our file stream set up and our binary writer set up, we can actually start writing data into the file. Okay, because all of our data was there in the student array, and our student array had 100 records. What we've done is we've set up a loop which is going to run 100 times, and each time the loop runs, we use the binary writer, and we use the built-in function called write. So binary writer has a built-in function called write. We use that function to write down one field of our record. So the first time, what in this line we are trying to write the name down into the file, right? And we are using the built-in function write. In this line we are trying to write the ID into the file, the student ID into the file, and in this statement, in this instruction, we're trying to write the field called height, right? So we're trying to write the student height into the file, and this loop, so this is one complete record, right? And this loop is going to run 100 times, and each time is going to move on to the next record in the array, and it's going to add those records into the binary file. So what we are doing here effectively is that we are taking all the records, all the 100 records from our student array, and we are writing them down into the binary file. And just like we used to work with text files, here also we must make sure that once we are done writing, we must close the binary writer. So we must use the built-in function called close to close the binary writer, and once again we must also make sure that we close the file stream also. Remember, this carries marks, okay? So you make sure that you close the binary writer and the file stream once you are done writing into the file. Okay, so what if you want to read from a binary file? In this case also, what you'd want to do is that you'd want to set up a file stream just like you set it up for a binary writer, but in this case you want to read from the file. So in this case, what you want to, and because you want to read from an existing file, open is a good option, right? File mode.open, this opens up an existing file. So because you want to read from an existing file that already has data in it, file mode.open is a good choice, right? Okay, now in this case what we've done is, because we want on this file stream, from this file stream, what we want to do is we want to read data, and for this what we've done is we've set up a binary reader. We've called the constructor of this binary reader class, and we have linked it to this file stream, right? Remember, fs is the identifier of this file stream, and we have linked it up to our binary reader. Okay, now we want to read as many records from the file as there are in the file. So what we want to do is we want to read all the records in the file, but we do not know, for example, how many records are there in the file, right? So for example, if we don't know how many records are there in the file, what kind of a loop can we set up so that, you know, once we've read the first record, then we go read the next record, then we go read the next record until we reach the end of the file, right? So we keep reading records in this case until we reach the end of the file, right? So if the file has 100 records, you know, we'll end up reading all the 100 records, and if a file has, let's say, 500 records, we'll keep reading till we reach the end of the file. That way we'll read all the 500 records. Okay, what we've done here is we've set up a loop which runs on this condition, right? And what is the condition? This is the length of the file, okay, the total length of the file, and this is the position of the cursor, right? So at the start, when we start reading, for example, let's say this is the end of the file, so we have records up till this point, right? Let's say this is the end of the file, right? In the beginning, our position of the cursor is right here. Once we read a record, the cursor moves forward. Then we read something else, the cursor moves forward. Then the cursor moves to the next line, and it's positioned here. When we read something else, the cursor starts, it keeps moving forward until the cursor position reaches this point, right? And that is when the cursor position, this condition proves to be false, right? So once our cursor position is greater than the length of the file, right, that is when this loop stops. Okay, alright, so what is happening here is that we already have that array, right? And what I've done is I have probably not used the right so this time our array is called student. It should not be student, right? It should be student array. Let me just rewrite this piece of code. Okay, so now what we have here is we have the student array, which was, remember, this was our array which can store records, and we are using the binary reader to read a string first, then read an integer, and then read a decimal value from our file. Okay, just remember this, that this is a binary file, right? This is a binary file, and in a binary file it is different from text file because everything you save in a binary file is saved in its internal representation, meaning name is a string value. So when we save a name in the binary file, it gets stored as a string value. But when we store an integer into the binary file, so remember this was the name, right? This was what we were storing, the name, and this is where we're storing the ID, right? And the ID is basically the data type of ID is integer, so this gets saved as 2's complement, right? So this gets saved in its internal representation, which is 2's complement, and then this is what the height is, a decimal value. So the height, if we were trying to save a height in the binary file, this would get saved in a floating point representation, right? This would have a floating point representation. So you should understand that when we are writing data into a binary file, it gets saved in its internal representation. Okay, that is why when we are reading the name from the file, we know that the name comes first, right? We are reading a string value. After that, we know that the ID is stored, therefore we are trying to read br.readInt. So the built-in function is readInt, right? It's readInt 32, right? But I believe in the exam, if you only write something like this, br.readInt, this should be acceptable also. Okay, and finally, this is another built-in function, br.readDecimal, in which you can use this to read decimal values from a binary file. So once again, you should remember that in this case, when we are reading a file, we must know the arrangement of our record, right? We must know what was the first field that was stored in the in the record. The second field was ID, and the third field was height, right? So we must know the sequence in which all these fields were saved in the binary file, that so that we are sure that at first we are reading a string value, then the second one, the second field is an integer, and then the third field is a decimal value. Okay, now that we loop through our file and we read the entire file. Once we are done reading the entire file, there's only one thing that we need to do, and that would be bw.close. we want to close the binary writer, and fs.close. we want to close the file stream also. Okay, the only key concept when we were reading from a binary file was this condition, right? This is the cursor position, and the cursor position keeps moving. Once you read a string value, the cursor moves forward. Then you read the integer value, the cursor moves forward. Then you read the decimal value, the cursor moves forward. We have at this point we've read one record, then we increment the value of I by 1 and we go back up. We start the loop once again. So we read the name again, the cursor moves forward. So we read the string value, we read the integer value, we read the decimal value. As we go on reading, the cursor keeps moving forward and forward and forward until it reaches the end of the file. At this point, this condition is going to be false, and when this condition is false, we exit the loop, meaning we've read all the records, and then we should close down the binary file and we should close down the file stream.